Imagine for a second that you are a high-end architect.
Okay, I'm tracking.
You've just landed a brand new client, and you're sitting across from them at this polished conference table. You have your blueprints rolled out, your fancy pens are laid out, and you are completely ready to design their dream home.
Right, the whole setup.
Yeah. But this client has some stipulations that are, well, frankly, bordering on the absurd.
Uh-oh.
They tell you that the front door of this new house needs to be measured down to the absolute millimeter. Like, if it is even a fraction of an inch too wide, the deal is completely dead.
Wow.
And on top of that, if the elevation of the front porch isn't angled perfectly toward the street, with a really specific type of loose gravel sitting right out front, they are going to literally spit dirt in your face.
Yeah, that sounds less like an architectural project and more like, I don't know, a psychological endurance test.
Right.
Most builders would just roll up those blueprints, pack up their pens, and walk right out of the room.
Oh, I would absolutely walk out. But for you, the listener joining us today, we are inviting you into a fascinating deep dive into a very specific, almost unbelievably demanding type of microarchitecture, where walking away just isn't an option.
Definitely not an option.
Because we aren't talking about human clients today. We are exploring the intense, mathematically rigorous world of the notoriously picky Apistogramma fish.
And it is such a phenomenal subject to dig into, mostly because it fundamentally changes how we perceive captive environments,
Yeah, totally.
When you look at the raw biological and just the spatial requirements of the Apistogramma, you quickly realize you aren't just dropping a plastic decoration into an aquarium.
Right, it's not just a toy castle.
Exactly. You are attempting to satisfy an ancient, hardwired set of engineering protocols that these creatures depend on for their very survival.
And as anyone who has ever kept an aquarium knows, the temptation is always there to just, buy a generic mass-produced resin cave from the pet store, drop it in the gravel, and assume the fish will just figure it out.
Oh, absolutely. It's the easy way out.
But before we can even begin to talk about the physical materials needed to construct a proper home for these fish, we really have to look at the math. Because the numbers they demand are staggering in their precision.
They really are.
Okay, let's unpack this. Let's start with the front door. The absolute requirement for the entrance of their breeding cave is an opening of exactly 1.5 centimeters to 2.0 centimeters.
Yep. Millimeter perfect.
We are talking about a doorway that is basically the width of a dime, maybe a penny at the absolute maximum. It's like a highly exclusive speakeasy door or a club bouncer's entry where it's exactly the width of the biggest guest's shoulders and not a millimeter wider. Why are they so obsessed with this microscopic margin of error?
Well, it comes down to a biological concept called sexual dimorphism, which essentially means the male and female of the species have distinctly different body sizes and shapes.
Okay.
So in Apistogramma pairs, the male is the larger, more robust of the two.
Yeah.
That strict 1.5 to 2.0 centimeter measurement is not arbitrary in the slightest. It is perfectly calibrated to the exact physical dimensions of the adult male's body.
Oh, wow.
Yeah, the doorway is engineered so that he has to just barely squeeze himself through the opening.
But wait, why would an animal actively seek out a tight squeeze for its own front door?
It seems counterintuitive, right?
Completely. Logically, I would think you want a door you could easily glide through, especially if you need to make a quick escape. I definitely wouldn't want a front door to my house where I have to suck my stomach in and scrape my shoulders just to get into the living room.
No, you'd hate that.
It sounds claustrophobic, and honestly, it sounds like a trap.
Right, but it would only feel like a trap to you because you don't live your life under the constant threat of a larger predator following you into your bedroom.
Fair point, yeah. I don't have that problem.
For the Apistogramma, that tight physical squeeze isn't a restriction at all. It operates as a tactile feedback mechanism.
Wait, a tactile feedback mechanism?
Right.
Like a sensory trigger?
Precisely. Think of it like the deep pressure of a weighted blanket or like a specialized athletic compression garment.
Oh, I see.
When the male fish feels the physical sides of the entrance brushing against his scales and fins as he enters the cave, it sends a direct neurological signal to his brain that the space is secure.
So his body is the measuring tape.
Exactly.
Yeah.
His body operates as the ultimate measuring tape. If he can just barely fit through the gap, basic physics dictates that absolutely nothing larger than him can possibly get inside.
Right.
So that physical restriction is exactly what triggers the feeling of safety. If the door's even half a centimeter wider, he doesn't get that tactile feedback.
Because he's just swimming right through without touching the sides.
Yep. A wider door doesn't feel like freedom to him. It feels like an open invitation to a predator. It feels like a massive vulnerability.
That is wild. That reframes the entire concept of a doorway for me.
It's pretty amazing.
The door isn't just an entrance. It is a physical security scanner. Like, it's the alarm system and the deadbolt all rolled into one entirely passive structure.
That's a great way to put it.
But, this leads me to a massive geometric problem with the rest of the blueprint.
Okay, let's hear it.
So, they have squeezed through this heavily secured, dime-sized entryway. What happens once they are actually inside the cave? If the whole structure is just a 2-centimeter wide tube, they can't possibly raise a family in there. It's like,
They'd be completely stuck.
yeah, it'd be like living in a pipe.
No, they certainly can't do that. A hallway is great for hiding, but it is entirely useless for breeding.
Right.
And this is where the architectural blueprint shifts dramatically. The entrance is incredibly restrictive, but the interior cannot be. The internal space actually needs to widen out significantly.
How significant.
So somewhere between 5 and 10 centimeters wide.
And that is the spatial disconnect my brain is really struggling with. You have this tiny, highly restrictive 1.5 centimeter entrance leading into a comparatively massive 10-centimeter interior cavern.
Yeah, the proportions are crazy.
It feels almost like a magic trick. Like the TARDIS from Doctor Who or something. Tiny on the outside, spacious on the inside. How does a 2-inch fish justify needing a space that large once they are past the doorway?
Well, what's fascinating here is we have to stop thinking of the space as just a hiding spot where the fish go to rest or, avoid bigger tank mates.
Okay, so it's not a bedroom.
No, it's a workspace. Once those eggs are laid, that cavern transforms into a highly functional industrial nursery. And running a nursery requires a tremendous amount of physical, continuous labor.
Labor that I assume is mostly being done by the female, since she's the smaller one who can easily navigate that tiny door.
Yes, she handles the bulk of the interior work. And once the eggs are attached to the walls or the ceiling of the cave, she doesn't just abandon them.
What did she do?
She has to actively and obsessively tend to the clutch. You see, in aquatic environments, stagnant water is a literal death sentence for fish eggs.
Oh, because of bacteria.
Fungal spores, mostly. If the water around the eggs isn't moving, microscopic fungal spores, things like water molds, will immediately take hold.
And I imagine that spreads fast.
Incredibly fast. A single infected egg can wipe out the entire generation in a matter of hours.
Oh, wow.
So the female has to act as a living water pump. She constantly fans the eggs with her pectoral fins to ensure fresh, oxygenated water is continuously flushing over the boundary layer of the eggs, keeping the fungus away.
Which means she really needs room to operate. She can't do that if she is pinned against a wall.
Exactly. The 5 to 10 centimeter width provides her with a necessary physical turnaround radius.
Oh, that makes so much sense.
Imagine trying to vigorously sweep the floor of a narrow coat closet while you are locked inside it.
You'd just be hitting the walls.
Right. If you don't have the room to rotate your body, you are going to be smashing your elbows into the walls and you won't be able to reach the corners.
It's pure logistics.
Exactly. The interior volume gives the female the spatial clearance to fan the eggs, to pivot rapidly if she needs to inspect a different section of the clutch, and to maneuver her body without accidentally crushing the delicate eggs with her own tail fin.
That is brilliant.
The function of the outside of the cave is entirely about exclusion and security, but the function of the inside is entirely about dynamic, continuous movement to keep the baby fish alive.
Okay, so we now have a complete mathematically verified blueprint. We need a structure with a 1.5 centimeter highly exclusive security door, which opens up into a spacious 10 centimeter functional nursery room.
You've got it.
But as anyone who has tried to breed these fish knows, you can't just drop a mathematically perfect dome into the center of an aquarium and expect the Apistogramma to immediately sign the lease.
Oh, definitely.
Because as demanding as they are about the dimensions, they also demand total control over the surrounding neighborhood, right?
They are the ultimate micromanagers. You might be providing the structural shell, but they demand the right to manage the landscaping.
Here's where it gets really interesting, because this brings us to the behavioral architecture of the species, which is honestly my favorite part of this entire deep dive.
It is pretty incredible.
It isn't just about the physical cave. It is heavily dependent on where that cave is placed. The placement rules dictate that the opening needs to be slightly elevated or tilted downward, with a specific type of substrate-like fine sand or very small gravel situated directly in front of the door.
Yes, the front porch area.
Right, the porch.
Yeah.
And this is where The female turns into, like, a heavy machinery operator. She will literally pick up mouthfuls of sand from that front porch area and spit it aggressively at the entrance of the cave to artificially shrink the doorway.
She essentially becomes her own general contractor.
It is such an incredible visual. But, when I first learned about this sand-spitting behavior, my immediate reaction was, well, I felt offense on behalf of the builder.
Really?
Yeah.
Why?
Because think about it. If I spend an entire afternoon meticulously designing and drilling a millimeter-perfect 1.5 centimeter hole, and the moment the client moves in, she starts throwing dirt at the door to close it up.
You take it personally.
I would. I would assume I failed. I would assume she hates the doorway and is trying to fix my sloppy work. Like, are our careful measurements just a total waste of time?
Well, it is entirely intuitive to feel that way, but if we connect this to the bigger picture, you have to look at the behavior through the lens of their natural ecology.
Okay, how so?
Her behavior isn't invalidating your measurements. In fact, it is the ultimate validation that you got the measurements completely right.
Wait, how is dismantling my carefully measured door a sign of success?
Because in the wild, Apistogramma live in incredibly complex, chaotic river environments in South America. These Amazonian tributaries are dynamic. The seasonal floods roll through, the water flow shifts direction, and the sandy riverbed and leaf litter are in a state of constant, unpredictable change.
So they are used to having to adjust things.
Exactly. Their instinct to excavate, to move sand, and to modify their own burrow is deeply neurologically hardwired into their reproductive cycle.
Oh, wow.
Yeah, so if you place a perfectly measured cave into a tank and the female just hovers there passively without touching the sand, it means she doesn't feel comfortable enough to start the breeding process.
The environmental triggers are missing.
Right.
So the physical labor is the biological proof that she feels at home. Like, if she isn't digging, she isn't breeding.
Precisely. When you see her picking up sand and spitting it to narrow the doorway, she is signaling that her deepest natural instincts have been successfully activated.
That is so cool.
She has evaluated the structural integrity of that 1.5 centimeter entrance. She has mapped out the 10 centimeter turning radius of the interior, and she has made the calculation that this space is secure enough for her to begin her final instinctual modifications.
Oh, yeah.
You have to provide the correct foundational canvas, the specific tilt, the proper elevation, the loose sand out front, so she can actually perform the behaviors she evolved over millions of years to perform.
Knowing these incredibly strict demands for spatial geometry and this deep psychological need for substrate interaction, it suddenly makes perfect sense why those generic plastic pet store castles fail so miserably.
Oh, they don't stand a chance.
Right. A brightly colored plastic shipwreck doesn't have a perfectly measured 1.5 centimeter door to provide that tactile weighted blanket feedback.
Nope.
It doesn't have a smooth 10 centimeter turnaround radius for fanning eggs. And it certainly isn't designed to be half buried at an angle in the sand so a fish can perform complex landscaping.
Not at all.
So if artificial containers are completely off the table, what materials can an aquarium keeper actually use to meet these absurdly high standards?
Well, this is where the aquarium keeper has to step away from being a consumer and really become a DIY engineer. You have to seek out materials that mimic the natural, organic shapes, textures, and structural integrity they would utilize in a wild riverbank. And there are two incredibly effective, albeit unconventional, solutions that hobbyists have perfected.
Let's hear them.
The primary, most reliable one is actually just the standard terracotta garden pot.
But obviously you can't just take a flowery pot you bought at a hardware store and drop it into the tank. The top of a pot is a giant gaping cavern. That violates every security rule we just talked about.
You definitely have to heavily engineer the pot. The process involves taking a small terracotta pot and flipping it completely upside down so the wide open top is sitting flat against the glass bottom of the aquarium.
Oh, I see. So that naturally creates that spacious 10 centimeter interior dome that the female needs to maneuver.
Exactly. But then comes the real challenge. You have to get a power drill with a specialized masonry bit and very carefully bore a 1.5 to 2.0 centimeter hole straight through the fired clay side of the pot.
Which sounds incredibly stressful, because terracotta is notoriously brittle.
Very brittle.
Like, if you push too hard, or if the drill speed is wrong, the entire pot will just shatter into jagged shards in your hands.
It requires an immense amount of patience. You are essentially doing delicate masonry work for a fish.
That's hilarious.
And even after you successfully drill the hole without shattering the pot, you can't just place it flat on the bottom. You have to remember the placement rules.
Right, the front porch.
Yep. You have to bury it deep into the substrate at a very specific angle, ensuring that the custom hole you just spent an hour drilling is slightly elevated off the sand, creating that little front porch area for the female to access the loose substrate.
It is a remarkable amount of physical labor and stress. You are taking power tools to gardening supplies just to satisfy the architectural whims of fish that is, at most, 2 inches long.
It's a labor of love.
So what does this all mean? Well, as intense as the terracotta process is, the alternative material hobbyists use is even funnier to me, just based on the pure logistics of it: coconut shells.
Coconut shells are arguably the most naturalistic option, actually. Yeah, they have the perfect, smooth internal volume. The fibrous exterior mimics sunken wood, and they are significantly easier to drill through without the risk of shattering like clay.
Which is great if you live near a palm tree.
Right.
But think about what this means for a person trying to build this setup in a modern city. It highlights this deeply humorous irony about urban sourcing.
Oh, the sourcing is a nightmare.
If you live in a dense concrete metropolis, you can't just walk into a giant mega mart and buy half a hollowed-out, perfectly sized coconut shell from the pet aisle.
No, you have to go on a hunt.
You have to navigate traffic, ride the subway, and wander through tiny local grocery shops or specialty produce markets just to find a whole, intact coconut.
Which is only step one.
Yep.
Because once you interrogate a produce clerk and finally buy your coconut, you have to bring it back to your apartment, you have to drain the water, take a saw to crack it perfectly in half, spend an hour scraping out the dense meat, boil the shell to remove the excess tannin so it doesn't turn your aquarium water pitch black.
And then the drill.
And then finally, get your drill out to bore that millimeter-perfect doorway.
Exactly. Picture the absolute absurdity of this scene. You are a modern person living in an apartment building in a concrete jungle. You are spending your Saturday afternoon doing messy, sticky carpentry on a piece of tropical fruit.
Covered in sawdust.
Covered in sawdust and coconut water, wielding a power drill. Well, wielding a drill all to satisfy the unyielding demands of a tiny fish that will probably spit dirt at your finished product anyway.
It is a stunning, almost comical display of dedication.
It really is.
It is a profound level of dedication, but it speaks to the very core of what makes building these specific environments so captivating. When you are doing this, you aren't just acting as a pet owner feeding a fish in a glass box.
Yes.
You are acting as a facilitator of natural ecosystems. You are trying to perfectly translate the chaotic, invisible perfection of the wild Amazon basin into a glass enclosure in your living room.
And to you, the listener, I think that is the ultimate takeaway from this deep dive. When we started this conversation, we joked about the nightmare scenario of an architect dealing with a demanding client who wanted a millimeter-perfect door and demanded a front porch designed for dirt spitting.
The worst client ever.
But seeing the immense, almost ridiculous lengths we must go to, trading out easy, mass-produced plastic castles for hand-drilled, shattered terracotta pots and scavenged urban coconuts, it reveals something profound about what captive environments actually require.
It really does.
We aren't just providing filtered water and daily food. By honoring these bizarre mathematical rules, we are trying to replicate the incredibly delicate psychological support systems that these creatures depend on to feel alive.
And this raises an important question, right? Stepping back from the aquarium, looking at the broader natural world, this level of microscopic engineering leaves us with a staggering realization. If a single 2-inch apistogramma requires this level of highly managed, meticulously angled, millimeter-perfect architecture just to feel secure enough to lay its eggs in captivity, what does that tell us about the hidden complexity of their natural river habitats?
Wow, yeah.
The rivers they originate from aren't just flowing bodies of water. They are vast, intricately balanced cities of biological architecture. It forces you to wonder how many other invisible doorways, tactile security scanners, and perfectly measured spaces exist out there in the wild, holding entire massive ecosystems together, entirely unseen by human eyes.
It really changes your perspective on everything beneath the surface. Next time you look into a fish tank and see a tiny fish hovering near the sand, just remember, you aren't just looking at a pet. You might be looking at a master architect, patiently waiting for the perfect door to open.